Welcome back, aliens. My name is Navin Reddy, and in this video, we'll talk about multi-threading. So basically, we'll work with threads. Now, in this particular section or video, depending upon how you're watching this, we are going to talk about what is thread. We are going to talk about why do we need threads and how exactly it works. And then we'll also move towards multiprocessing. So we'll try to understand how multiprocessing can be useful over threads in some use cases. So let's start with an example, okay? And then we'll start with the code, and then in between, I will give you some analogy to understand why we need threads. So let's create a file here. So let's go back to our advanced project, and let me create a simple file. So I will say this is threads demo.py, and in this, let's create a simple example. So whenever I want to teach threads, I normally take this example of hi and hello. Okay, very lame example, but it shows you the importance of threads. Okay, so bear with me. Logic is not important. What you're getting in the output is not important, but the use of threads are important here. So what I'm going to do is I'm going to create a class. Now see, when you talk about threads, again, we have not talked about what is thread, but when you talk about threads, we can create threads in two ways. One is using classes, and the other way is using functions, which is a Pythonic way. So I will show you both, don't worry. So I'm going to create a class called hello. Very simple example, a very simple class. In this, I'm going to create a function called do, which will do something. And since we are writing this inside of class, let's pass self there. And in this, it's going to print something. Now, we can print amazing stuff, but let me just print hello. And I'm going to do that. I'm going to print that 5 times. So let's say for I in range, and since we want to print it 5 times, I will say range of 5. And every time I'm going to print hello. And then after printing hello, I'm also going to print the time it is printing. I'm not the time, but the occurrence. So I will say I. So it will print hello 1, hello 2, hello 3. In fact, for that, I should say I plus 1. So it will print hello 1, hello 2, hello 3. That's what we want. And then I want to do the same thing to one more class here. So let's say in our case, it will be hi. So we got 2 classes, hello and hi. And here we can print hi. And then I can just simply execute them. So let me do that in if name is equal to main. In this case, I want to create object of both the classes. So I will say obj1 equal to hello and obj2 equal to hi. But time in I will just name it as t1 and t2 because we are going to need these names later. See, name doesn't matter, right? So we got 2 objects. And with those 2 objects, I can call those functions. So I can say t1.do, which will call the do function of hello, and t2.do, which will call the do function of hi. And both of these are going to print the same thing. Not exactly the same thing, but same pattern, right? Hello 1, then hi will print hi 1, and list goes on. So let's see if this works. Nothing complex, right? Simple example, very weird examples. Simple and weird, but then it will make sense, don't worry. And here, let me first of all move to the advanced folder. And now let's run this. So I will say Python threads demo.py. And let's say enter. So before I say enter, in your mind, just write on this and let me know what is the output. Maybe you can use a comment section or wherever place to answer this. Think about this and answer. Now, when I try to run this in my mind, what I see is I'm calling do function of hello, and then I'm calling the do function of hi. It will first, so we have the flow. So the flow will start from here. Of course, this will create these 2 things, but it will also go here and it will check what we are doing here. We are creating the object of hello. We are creating the object of hi. It will do that in sequence. And then it will go to this particular call. It will say, okay, it's my job now to execute the do function of hello. It will go there. It will complete the entire task. Now, when I say entire task, nothing complex. It will execute this for 5 times. And 5 times it is going to print hello with different numbers, of course. And once it is done, the pointer or the flow will go back to here and then says, this is done. Let's go to this particular function, execute this, and this will execute hi 5 times. So that means the output I'm expecting is 5 times hello, 5 times hi. And let's see if it is matching with our dry run. Let's run this. And yeah, that's what we got. We got hello 5 times. We got hi 5 times. We got what we wanted. But now I want something else. I'm greedy. Okay, so what I want now is I want to print hello and hi simultaneously. Now that's weird. Why someone will need that? We'll talk about that in some time. Why? But let's say I want it. I want to print hello, then hi, then hello, then hi. May not be in the perfect sequence, but I want these two functions to run parallelly. At this point, we can't do that because that's how your code runs, right? Step by step. It will execute this, complete the task, then only it will go for the next step. Now I want both these functions to run parallelly. How will you do that? Now, for that scenario, we have to use threads. But before we go there, let's talk about why. Why do we need it? Why do you want to execute two functions simultaneously? See, when you play a game, or in fact, not just game, whatever application you use nowadays, they all have this feature where you can execute multiple things at the same time. Example, let's say if you are using your phone, and normally we have this tendency when you get a call from someone, and if you know you are going to talk to them for a long time, and it's not an important discussion. I mean, of course, it's important, but then not critical. So while talking to them, let's say for half an hour, you minimize the call and then you open some other application, maybe your WhatsApp application, or maybe if you are watching some cricket match or cricket score. So at the same time, you're talking to someone. At the same time, you are opening a cricket application to watch the score or to update yourself. And then at the same time, maybe you're opening WhatsApp to chat to someone. So you're doing multiple things at the same time. As a human, we can do that, not perfectly. But what about your OS? What about your phone? Can it execute multiple things at the same time? It can, right? So if you say call is one function, WhatsApp is another function, your updating your cricket score is one function, you are executing all these functions simultaneously. We can also look at the example of game. When you play a game, so I was a big fan of NFS, or maybe Mario. So I don't know how many of you know Mario games. So let's say if you play a Mario game, so what happens is there's a player, or which is you. Basically, you are trying to cross certain hurdles and you are jumping, you're getting stars, you're getting all those features. Okay, I will ask my editor to put some Mario screenshot on the screen to make you understand that. So in this game, basically there are multiple things happening at the same time. You are moving, you're jumping. At the same time, the enemies are coming towards you. They're trying to hit you. At the same time, there's a music playing. At the same time, there's a score updating. So a lot of things are happening, right? Now, if you say you are moving is one function, the enemies are moving is one function. I mean, of course, there will be multiple functions for the enemies because there are different enemies there. Then there's score update for one function. There's music, one function. All these functions are executing at the same time. I mean, simultaneously. So if you don't have this feature of executing them simultaneously, then what will happen is you are moving, then you are stopping, then enemies are moving, then they are stopping, then music is playing, then that is stopping, then score is updating, then that is stopping. So we don't want that, right? We want everything to run simultaneously. And that's what I want here. I want this hello and hi to execute simultaneously so that we can mimic that feature. How do we do it? And that's where we can use threads. Now we can do that with the help of threads. Okay, so executing multiple things. Now what are threads? Now in your system, there's something called process, right? So whatever you execute is happening with the help of process. So if I show you, if I open my task manager, it opened here. So that's my task manager. And so you can see multiple things are executing at the same time. So we got a PowerShell, we got console, NVIDIA app, because I'm recording the video, so it is using that. Claude is open, I don't know why. Edge is open, I don't know why. So a lot of applications are running at the same time, right? But if you go here to this particular section of performance, you will see there's something called process. So when you execute this multiple applications, they are using process behind the scene. But then process itself is a heavy thing. To create a new process, it takes time, it has its own memory. So of course, to execute things simultaneously, we can use process. But as I mentioned, it is heavy, it has its own memory, so you're wasting a lot of memory there. What if you want to create a smaller version of it? You want to create a lightweight version of process, and that's where you get threads. So in one process, we can have multiple threads. And as you can see, whatever application I'm running, of course, I'm not running 5,000 applications here. But if you see threads, there are more than 5,000 threads running now to do this. Maybe recording, because it's a heavy software recording it. The only thing is I'm not recording my face with the system, so it is not that heavy, but even recording the screen is heavy. But at the same time, if I open some other application, let's say IntelliJ, it might spike this. So if you can see it is opening, it went up. So the more applications you have, the more threads it's going to use. And you can see the consumption just went up. Let me close this. I don't want IntelliJ at this point. So it will drop. The number of threads required now will go down. Exit. So you got the point, right? So threads are the lightweight process. You can say that. The question is, how do we create one? So if I go back here, how do we create threads? There are two ways. You can directly create a thread here. So you can say thread, and then in this thread class, so the thread is basically a class and you have to import that. So I can say from threading module, I can import thread. And if you look at thread, it's a class. Okay, so if you have a class, you can create the object. So you can see we are creating the object here, and you just have to specify what is your target. So you can say equal to hello.do. So this is how you mention your target. So you mention the class name, because see, if you just create a thread, how it will know when you execute this thread, which particular class method is going to execute or the function is going to execute. So you do like this. But I don't want to do in this format. I will simply say hello here, because we are going to see that format later. So let's see the normal inheritance way. So if you want to make this hello as a thread, if you want to run them simultaneously, you have to make them threads. So what you can do is you can say, you can inherit thread for both hi and hello will inherit thread. Now, the benefit which you get is, first of all, these are not normal classes now. These are threads because you are inheriting thread. It's something like if you inherit Bill Gates, you become Gates. Right? You will be rich in one day. Okay, doesn't matter. So hello got all the features of threads because it is inheriting threads. Now this T1 is T2, not normal objects, they are threads. And with threads you get superpower. And to get that superpower, let's change our function name from do to run. So you have whatever function name you have, replace that with run, because thread runs. So you have to make sure that you keep it run. And then here you will call run. So simple, right? Let's see if this works. Let's go back. Hopefully it's going to execute them simultaneously now. So let's try this, enter. Oh, it's not happening simultaneously. It's still going in sequence. Why? Why it's going in sequence? It's because we have two threads, no doubt in this. It's just that they are not active. What I'm expecting is there is one particular process which is executing this, and now I want two threads out of it. So there should be a bifurcation of two threads, and these two threads are going to execute hello and hi running simultaneously. That's not happening. It's because we are not starting the threads. But you will say, hey, we are running the threads, right? It should work. Now, thread says, if you want me to work the way you want, start me, don't run me. So you have to say t1.start and t2.start. Then there's a problem here. The problem is the function name is run and you're calling start. How that works? Let's see if this is working with this code. So I'll just save this, clear the screen, run. It's working. Can you see that? Something is happening parallelly. Okay, so not exactly the sequence I want, but hello got printed 3 times, then hi came in between, and then hello, then hi, then hello. Something is happening, okay? So not exactly the sequence of hi, hello, but two functions are running simultaneously. That's what we wanted, right? But let me answer this question. When you're calling start, how it's calling run? See, behind the scene, when you say t1.start, behind the scene it will go to your system and say, okay, now user wants me to start. And then it will start behind the scene and it will call run. That's not our lookout, that's a lookout of your system. Okay, so internally start will call run. So you do need run there. If you have some other function, it will not work. So let's say if I have do there, and if I try to run with do, nothing is happening. Okay, so T1 or this particular function is not getting called. But there's no error. Where's run? Run is there implemented by default in thread. So if you search somewhere, there should be run. Okay, so when you call start, start will call run, and this is a run function. So even if you don't mention, it is there. But I want my run function. So you should say run. Okay, so this is working. But then you will say it's not what I wanted, right? I want in proper sequence. First of all, let's try to understand how it is happening. Why? Okay, by the way, when you saw the output initially, it was hello 1, hello 2, hello 3, then hi 1. So the sequence is not confirmed. So what is happening is, in our brain, we are expecting when it goes to your system to execute, to your CPU, it says, hey, execute this. We are thinking that T1 and T2 will take turns and say, hey, T1 will execute, then T2 will execute, then T1 will execute. But then, depending upon your system speed, now this will change in your system as well. Depending upon your system speed, depending upon how many other processes are waiting to execute on your CPU, When T1 goes to your CPU, it will say, hey, I want to execute. CPU says, let me check. I have other process to execute. And once it gets free, it will say, now T1, it's your turn to execute. Now, in that turn, whatever time specified to T1, in that specified time, it might execute this loop once, twice, thrice, or maybe 5 times. You don't have a control. In this case, it's executing only 2 times. And then CPU says, your job is done. Let me give chance to some other process, maybe some music app which is running behind the scene. And yes, Spotify is running behind the scene. Let me close this. And some other application running behind the scene. And then it gives chance to high to print. And then high is doing its job. And then it is printing only once. And then again, the chance is given to hello. It is executing 2 times. And we don't have a control on that. The only thing you can do is, since hello is executing a bit fast, I can just slow it down. And the way you can do that is by importing from time import sleep. This is what you can do. And every time this execute, I can ask it to sleep for some time, maybe 0.3 seconds. And I'm just trying to do that, okay? It's not like CPU will listen to me. I mean, of course, CPU will sleep for 0.3 seconds, but it will not guarantee the sequence which we want. So we got high 1, hello 1, hello 2, hello 1, hello, high 1, hello 2, high 2, it messed up here. So you can see high is getting printed 2 times. We can add a delay between the calls as well. So maybe one will start after the other with a delay so that they will not reach at the same time. And no, I can just delay it, increase it by bit late. You can only try. You can see it is working this time, but I'm not sure if I run this once again. Yeah, it messed up. So you don't have the exact control on this scheduler. Yeah, that's what handles the execution of the threads or the process. But we can try. And with sleep, I try to do that. But intentionally, we are slowing down our system, right? Not a good idea, but just to show you how things works out. So this is how you do it with the help of class. But what if you want to do this with methods or functions? Let's try that. For functions, what you can do is you can use these functions without classes. Let me remove classes. And let's put that here. One more thing will change. We can change the function name. Instead of run, we'll say hello and hi. Now, since it is not inside the class, I can remove that self. And then here, instead of getting the object, I have to create threads now. Okay. So things will remain same. Nothing changes apart from removing the class. And here, because we don't have a class, right? So I have to create the object of thread. And in this thread, I have to pass the target. So for this thread, which is the target function is hello. The same thing. Okay, why thread is not working? Oh, my bad. I'm saying target there. Happens with most of us. So I will say target, and this time the target is high. So we got the target hello. We got the target high. So when T1 executes, it will target hello. When T2 executes, it will target high. That's what I want. Let's see if this works in the same way. Yeah, same way. You can see we have 2 options. Either you can use class approach or you can use functions approach. The more Pythonic approach is functions, so you should use this. But I wanted to show you the class approach as well, in case if you see some code which has a class, you should know what is happening. Now let me show you one more thing. So let's say at the end here, I want to say bye. Okay, so simple stuff. At least when you execute the code, when it ends, greet the user by saying bye. Okay, so when I say enter, I'm expecting bye at the end, but see what happens. Bye is coming here. That's weird. Why it will come in between? It should be at the end, right? See, the thing is, when it starts, okay, we have a single process which is executing this, which is executing this. And then at this point, we are creating 2 threads, right? And then these 2 threads, one will execute hello, one will execute hi. But what about the thread which started this? The middle thread. It is still empty, right? It's not doing anything. Not empty, but it's idle. It's not doing anything. So that thread will say, okay, my job is done creating this 2. I will continue and I will print bye. That's what is happening here. How will you pause it? We should ask that main thread or the middle thread to wait. Let them complete their work. T1, T2, let them complete their work. Once they come back, then execute bye. So how will you wait for the other threads to complete? In this case, you will say T1.join, T2.join. Basically what you're saying is you're saying wait for them to complete, let them join back. Once they join back, then execute bye. So that's the importance of join here. So if I run this, you can see bye will get executed at the end. So the middle thread will wait for the other 2 threads to complete. or to complete and join back, come back and join. So that's how it works. That's how join works. Now to make this better, we can use another example. See, till this point, we know threads are useful, but I want to see, does it also increase the speed of execution? And for that, I'm going to use some other function now. So let me remove this too. And let's create a function called download, okay, which will download the files. And I will say file name here. So it will download some files, and we are not literally downloading the files. So you have to write a lot of code for that. And if you have free time, you can do that. At this point, I'm just going to say downloading files or downloading file ... And maybe we can also print the file name if you want. So we'll know which file it is downloading. And then since it will take some time, I will add a sleep of 1 second, or maybe 0.5 seconds also works. At least this much time will take to download. And then at the end, I will say download complete. Okay, so it will say downloading file. It will pause for some time and it will say download complete. Now I want to have, in fact, I will just keep it like this. Maybe let's change it and let's keep the by at the end. That is a good sign. Now what I want to do is I want to have multiple files. So I can say files. So let's say that we have different files here. One is video.mp4. Then we got image.png. And let's say we have one more file, which is data.csv. So we got these files and now I want to download them. So let's do that one by one. And if you want to do it serially, it's very simple. You can use a for loop and you can say for in files, and you can call the download functions for each file. Okay, and then you can download it. But I also want to know how much time it is taking to download the files. And before that, let me just run this and see if these things are working. It says downloading file, video, and it will go in sequence, right? It will first complete the video, it will then go for image, then it will go for data.csv, and then it will say bye. But I want to know how much time it is taking to do that. So I will say start time. We have to also import time here, sleep and time. So if you want to know how much time it's taking, so current time, and at the end, you will say time, and then you can simply subtract them. So I can print in a particular format. I will say serial time. I can put that in curly braces. It should be end minus start. That's how you find the time, right? End time minus start time. But it should be 2f. I don't want to print all the decimals, only 2 decimals. And I will say seconds. Simple stuff, nothing fancy, right? Let's see how much time it takes. Run. It is printing everything and it took 1.5 seconds. That's a good time. But now let's try to do that with threads. Okay, so I will just remove these extra spaces from here. So this is for serial. Let's do that with multithreading. Now for multithreading, we need multiple threads, right? And let's create the list of threads because we need 3 threads here. And that depends upon the number of files. So I will say for f in files. So depending upon the number of files, we'll create number of threads. So I will say t is equal to, let's create threads. And threads will have one target, which is the download function. But then download also need the argument, right? So download function needs an argument. So you have to pass the argument as well. So args equal to f, comma. So this is the syntax. You have to pass the comma as well. You have to mention the target, which is the function name, and then the arguments. Okay. And then we can simply add this thread to the threads. Append the thread. Now, once you got 3 threads, let's start those 3 threads. So for t in threads, t1 dot start. Simple, right? So depending upon number of threads, you have to start those threads. And then we'll also wait for the joining them because by should be printed at the end. So for t in threads, for each thread, wait them to complete their work and join. And before we start this download, or here at this point, I want to start the timer. So I will say start equal to time, end time, and then I can simply execute this part. Parallel with threads, and that's the time. So let's see how much time it takes now. Let's run this. So serial takes 1.5 seconds. You can see that. And the parallel takes 0.5 seconds. And things are happening parallelly. You can see downloading file this, downloading file image, downloading file data. And then all these things are getting downloaded parallelly, and then they are complete. That's what I want. Now, yes, people who will say, we have a limited bandwidth. It's better to download one file after the other, but let's say I have unlimited bandwidth. it works, right? So it saves time. So threads are useful, right? So it saves times. You can execute things parallelly. So what we are doing is we have 3 files. We are creating 3 threads for those 3 files. If you have more files, you can simply add them and it will do that. And in serial, that as the number of files increases, the time will increase. In fact, you can make it more interesting by specifying the file size, and that size will define the number of seconds it will take. So you can make it more dynamic. Okay, so you try that. That's your homework. Yeah, so that's helpful. Now let's see where threads can impact. So whatever we have done now is basically IO bound operations, and in an IO bound, threads make sense. But what if you are using CPU intensive work? And for that, let me take different example now. So instead of download, let me say, in fact, let me just clean this so that you will not get confused. And I also want to remove this part. I want to keep this because we'll need this part. I think I deleted end as well. We'll write it once again. So let's try with something. And yeah. So let me get a function and it will simply say calculate. So what we are calculating is whenever you get a range. So let's say n1 to n2. Now this can be any range. It can be from 1 to 100 or 1 to 1000 or 1 to 1 million. Now, whatever range you have, for that range, you have to find the square of each number and then sum it up. So we are basically doing the sum of the squares. And for that, we have a formula as well. Let's do that. So we'll say for I in range, and we can specify from where to where, from n1 to n2. Basically, we have to find this sum. So we also need to create this variable sum, which will be 0 in the case. And then we just have to say sum plus equal to n. This instead of I, so this should be n. Name doesn't matter, but it's good to have a good names. Even n1 and 2 are not good names. But this is what we're doing. We are basically doing the square of it, and then we are summing it up. This is a logic for summing all the squares. Simple, right? And I want to do this. I want to call this. Now, what should be the range? What should be the first number? What should be the last number? So let's create that. So I will say num is equal to, and we can have a range of 50. So from 0 to 50. But I want to do something weird. Okay, so I got this very big number, which is 50 million, and the range is 0 to 50 million. Now, output doesn't matter. So I'm not going to return this sum, and we're not concerned about the output. I'm just concerned about this speed. Okay. And let's do that in sequence. So at this point, I have this number. I will try to execute that calculator function by passing 0 to num, and let's see how much time it takes. Clear, run. So it is taking time. You can see it took some time and 1.59 seconds. That's a good time. Parallel says 0 because we are not doing anything here. At this point, we are just going in sequence. So that's the time. I want to see if I try to divide this into 2 parts, from 0 to 25 million and then from 25 million to 50 million. So we can have 2 threads running parallelly, executing the first half and second half. I'm expecting it should speed up. Let's see. It should complete in half a time, right? So let's create 2 threads. So T1, this is the thread. And the target for this is the calculate function. Now, calculate functions takes 2 arguments. I can pass the arguments. One is from 0 to midpoint, and we have to find the midpoint. So I will say mid is equal to num divided by 2 because I want integers. So I will just say /. So from 0 to mid will be T1, and T2, the second thread, will start from mid to the end. So this is T2. This will start from mid till the end. Okay, so we got 2 threads, one first half, second half. Okay, now let's start them. So I will say T1.start. Now since we are not using a list of threads, so we can do that now like this. We don't need for loop. And then we have to wait for them as well. So T1.join, T2.join. And now let's see how that works. So how much time it takes. Let's clear, run. The serial takes 1.67 and parallel is 1.57. There has been increment, but I'm just not sure is it only this time or every time. In fact, I was expecting half of a time. It's not half time. There's a minor difference. And maybe there will be a time where it will take more time than serial. Okay. But now the question is why it is not that fast if you are executing two things at the same time. See, what happens is when you have a CPU intensive work and when you have multiple threads running this, in our mind we're expecting that my CPU is multi-core CPU, right? So it should execute T1 on one core, T2 on another core. It should work parallelly and it should take half a time. But then that's not how Python works. In Python, there's something called GIL, which stands for Global Interpreter Lock. So what it does is, if you have multiple threads, it will lock one thread. So one thread will lock your interpreter, and then the second thread will wait for your execution time. So if T1 is working, T2 can't work because of GIL. And then once T1 is done, T2 will execute. And then if T2 is done, T1 will execute because of the GIL. And that switching takes time. In my version, it's not happening that often, but it is still not that fast, what we're expecting. So what's the solution? The solution is multiprocessing. So process and threads. Process are a bit heavy, as I mentioned before. So threads basically share the memory. Threads is lightweight. It is fast to create. Process, on the other hand, it takes time to create, but they have their own memory and they have their own GIL. So every time you create a new process, it will have its own GIL. So there's no locking problem. In terms of threads, they share the same GIL, or GIL in short. So how do you make it fast with process? So from multiprocessing, you can import the process. And the way you have done threads, we can do the same thing with process. The only thing you have to change is, instead of thread, you have to say process. And even here, you have to say process. I think I'm importing process. Oh, P small, capital P. Now there's no problem. Process. And let's see, parallel with process takes how much time. So let's clear this, run, and serial takes this much time. Parallel, if you can see, took more time than serial. But parallel process took 0.8 faster, right? So because of that GIL, threads were taking more time than serial. So if you have a CPU intensive work, I would stick to serial or I will stick to process. In process, you are wasting a lot of memory and time also to create those processes. So which is better? That depends upon situation. For IO bound, threads are better. If you want to execute something parallel, doesn't matter the speed, threads are better. But if you want to execute a different process with their own memory and GIL, you can use process. And it's very simple to use process. Just import from multiprocessing, import process, and your job is done. So yeah, that's it from threads. See you in the next part.